Top 25 Data Science Interview Questions and Answers. In the competitive field of data science, preparing for interviews can be challenging. This video will guide you through the top 25 interview questions that frequently arise, along with effective answers to help you stand out. Whether you're a beginner or an experienced professional, these questions cover essential concepts and practical applications. By familiarizing yourself with these topics, you'll enhance your confidence and readiness for your next data science interview. 1. Can you describe a data science project you worked on from start to finish? What were the key challenges? In a recent data science project, I developed a predictive model for customer churn in a subscription-based service. The project began with data collection from various sources, followed by data cleaning and preprocessing to handle inconsistencies and missing values. I faced challenges in selecting relevant features due to high dimensionality and ensuring model interpretability. After applying various algorithms, I ultimately chose a random forest model for its balance between accuracy and interpretability. The project culminated in actionable insights that helped the marketing team tailor retention strategies, significantly reducing churn rates. 2. How do you approach data cleaning and preprocessing? Can you provide an example? Data cleaning and preprocessing are critical steps in any data science project. I start by assessing the dataset for missing values, duplicates, and inconsistencies. I apply techniques like imputation for missing values and remove duplicates to ensure data quality. For example, in a recent project analyzing customer behavior, I discovered that some entries had incorrect date formats and missing demographic information. I standardized the date formats and used mean imputation for missing values. This prepared the dataset for more accurate analysis and modeling. 3. What techniques do you use for feature selection and why are they important? Feature selection is crucial in data science as it helps improve model performance and interpretability. I often use techniques such as recursive feature elimination, RFE, which ranks features based on their importance, and lasso regression, which can shrink coefficients of less important features to zero. Additionally, I employ tree-based methods like random forests that provide feature importance scores. Selecting the right features reduces overfitting, speeds up training, and enhances model accuracy, allowing for better generalization on unseen data. 4. Explain the difference between supervised and unsupervised learning with examples. Supervised learning involves training a model on labeled data, where the output is known. For instance, in a spam detection system, emails are labeled as spam or not spam. The model learns from these examples to classify new, unseen emails. In contrast, unsupervised learning deals with labeled data, focusing on finding patterns or groupings. A common example is customer segmentation in marketing, where the model groups customers based on purchasing behavior without predefined categories. Both approaches serve distinct purposes in the data science field, addressing various problem types. 5. How do you evaluate the performance of a machine learning model? What metrics do you consider? Evaluating the performance of a machine learning model involves several steps and metrics. Common metrics include accuracy, precision, recall, F1 score, and area under the ROC curve, AUC-ROC. For classification tasks, accuracy gives a broad sense of performance, while precision and recall provide insights into the balance between false positives and false negatives. In regression tasks, metrics like mean absolute error, MAE, and R-squared help assess model fit. The choice of metrics often depends on the specific problem and the implications of different types of errors. 6. Can you discuss a time you explained complex data findings to a non-technical audience? One instance was when I presented the results of a customer segmentation analysis to the marketing team. I used visual aids, such as charts and graphs, to illustrate key insights. I began by simplifying the technical jargon and focusing on the implications of the data rather than the methods used. By relating the findings to their marketing strategies, I highlighted how data-driven decisions could enhance customer engagement. The team was able to grasp essential concepts and apply them effectively in their campaigns, demonstrating the importance of clear communication in data science. 7. What is your experience with big data technologies like Hadoop or Spark? My experience with big data technologies includes working extensively with both Hadoop and Spark. In a previous project, I utilized Hadoop for storing and processing large datasets, leveraging its distributed file system, HDFS, to handle data from various sources. Additionally, I employed Spark for real-time data processing, utilizing its in-memory computing capabilities to speed up data analysis tasks significantly. This combination allowed my team to execute complex queries and data transformations efficiently, resulting in valuable insights derived from large-scale data. 8. How do you handle missing data in a dataset? What strategies do you find effective? Handling missing data is crucial for ensuring the integrity of a dataset. One effective approach is imputation, where I fill in missing values with statistical measures such as mean, median, or mode, depending on the data distribution. Another strategy involves using algorithms that support missing values, like decision trees. In some cases, I may choose to remove rows or columns with excessive missing data if they do not significantly impact the dataset. Each strategy depends on the context and nature of the data, allowing for tailored solutions to maintain quality in analysis. 9. Describe a situation where you worked with a team to solve a data-related problem. What was your role? In a project aimed at improving customer retention for an e-commerce platform, I collaborated with a cross-functional team that included marketers, product managers, and data engineers. My role involved analyzing customer data to identify patterns and trends. I performed exploratory data analysis and created visualizations to effectively communicate insights about customer behavior. Working together, we developed targeted marketing strategies based on data findings, which ultimately led to a 15% increase in retention rates over 3 months. This experience highlighted the importance of teamwork and clear communication in achieving shared goals. 10. What is your experience with A/B testing? Can you walk us through a specific example? In my previous role, I conducted an A/B test to optimize the conversion rate of a marketing landing page. We created 2 versions, version A with the original layout and version B with a new call to action button. We randomly assigned visitors to each version and tracked key metrics, such as click-through rates and conversions. After a 2-week period, data showed that version B outperformed A by 25%. This informed our decision to implement the new design across all campaigns, leading to increased user engagement and higher sales. 11. How do you stay current with the latest trends and advancements in data science? Staying current in data science involves a multifaceted approach. I regularly read industry blogs, research papers, and attend webinars to gain insights into emerging techniques and methodologies. Joining professional networks such as data science meetups or online communities helps me engage with peers and share knowledge. I also take online courses to deepen my understanding of new tools and frameworks. Additionally, participating in hackathons and contributing to open-source projects allows me to apply new skills in real-world scenarios, keeping my knowledge fresh and applicable. 12. Can you explain overfitting and how to prevent it? Overfitting occurs when a model learns the training data too well, capturing noise and outliers rather than general patterns. This results in poor performance on unseen data. To prevent overfitting, techniques such as cross-validation, regularization, and pruning are commonly used. Cross-validation helps ensure that the model's performance is consistent across different subsets of data. Regularization adds a penalty for complexity, encouraging simplicity. Additionally, using more training data can help the model generalize better, reducing the risk of overfitting. 13. What programming languages and tools do you prefer for data analysis, and why? I prefer Python for data analysis due to its rich ecosystem of libraries like Pandas, NumPy, and Matplotlib, which facilitate efficient data manipulation and visualization. R is another strong choice, particularly for statistical analysis and advanced graphics. For big data projects, I often use tools like Apache Spark for processing large datasets, as it provides speed and scalability. Jupyter Notebooks serve as an excellent environment for prototyping and sharing insights interactively. These languages and tools enhance productivity and enable effective communication of findings. 14. Describe a time you had to make a decision based on data analysis. What was the outcome? In a previous role, I analyzed customer churn data to identify key factors leading to attrition. After cleaning and visualizing the dataset, I noticed a significant correlation between customer support response times and churn rates. Based on this analysis, I recommended improving our support processes to reduce wait times. The team implemented a new ticketing system, which led to a 20% decrease in churn over the next quarter. This decision not only improved customer satisfaction but also positively impacted our revenue and retention rates, demonstrating the power of data-driven decision-making. 15. How do you prioritize tasks when working on multiple data projects simultaneously? When juggling multiple data projects, I prioritize tasks based on several key factors. First, I assess deadlines and urgency, ensuring that critical milestones are met. Next, I evaluate the potential impact of each project, focusing on those that align with organizational goals. Communicating with stakeholders is crucial. I gather insights on their priorities and expectations. I also break down larger projects into manageable tasks, using tools like Kanban boards to visualize progress. Regularly reviewing priorities ensures I stay adaptable in a dynamic environment. 16. What data visualization tools have you used and which do you prefer? I have experience with several data visualization tools, including Tableau, Power BI, and Matplotlib. Tableau stands out for its user-friendly interface and ability to create interactive dashboards quickly. I appreciate how it allows stakeholders to explore data dynamically. Power BI is also excellent for integrating with Microsoft products, making it a good choice for organizations already using that ecosystem. For coding-based visualization, I prefer Matplotlib and Seaborn in Python because of their flexibility and customization options. Each tool has its strengths depending on the project requirements and audience needs. 17. What role does domain knowledge play in your data science work? Domain knowledge is crucial in data science as it allows for a deeper understanding of the data and its context. When working on a project, Having insight into the specific field helps in identifying relevant features, interpreting results accurately, and making informed decisions. It also facilitates effective communication with stakeholders, ensuring that the solutions developed are practical and aligned with business needs. This understanding can significantly enhance model performance and lead to more impactful data-driven decisions, as it bridges the gap between technical analysis and real-world applications. 18. How do you ensure reproducibility of your data analysis and models? Ensuring reproducibility in data analysis and models involves several key practices. First, I maintain clear documentation of the entire analysis process, including data sources, preprocessing steps, and model parameters. I use version control systems like Git to track changes in code and datasets. Additionally, I utilize environments like Docker or virtual environments to create consistent setups across different machines. Lastly, I provide access to scripts and notebooks, ensuring that others can replicate the results without ambiguity. This structured approach fosters transparency and collaboration. 19. Can you explain the bias-variance trade-off in machine learning? The bias-variance trade-off is a fundamental concept that describes the trade-off between two types of errors that affect the performance of machine learning models. Bias refers to the error due to overly simplistic assumptions in the learning algorithm, which can lead to underfitting. Variance, on the other hand, refers to the error due to excessive complexity in the model, causing it to fit the noise in the training data, which leads to overfitting. Achieving the right balance between bias and variance is crucial for developing models that generalize well to new data. Techniques like cross-validation and regularization help manage this trade-off effectively. 20. Describe troubleshooting a model that wasn't performing well. How did you fix it? When troubleshooting a poorly performing model, I first analyzed the data for potential issues, such as outliers or incorrect labels. I then examined feature importance and correlation to ensure relevant features were utilized. Adjusting hyperparameters and experimenting with different algorithms helped in identifying a better fit for the data. I also implemented cross-validation to assess model stability. Finally, I revised the data preprocessing steps, focusing on normalization and encoding techniques, which ultimately improved the model's performance significantly. 21. How do you collaborate with stakeholders to understand their data needs? Collaboration with stakeholders involves active listening and clear communication. I start by organizing meetings to discuss their objectives and specific data requirements. During these discussions, I ask open-ended questions to gather insights into their goals and challenges. It's also essential to translate technical jargon into understandable terms, ensuring everyone is on the same page. I use visual aids to illustrate data concepts, making it easier for stakeholders to express their needs. Regular follow-ups and updates help maintain alignment throughout the project, fostering a collaborative environment and ensuring that the final deliverables meet their expectations. 22. What ethical considerations do you take into account when working with data? Ethical considerations are crucial in data science, particularly regarding privacy, consent, and data security. I ensure that all data collected is done with informed consent, respecting individuals' rights. Anonymization techniques are applied to protect personally identifiable information. Additionally, I evaluate potential biases in datasets that could lead to unfair treatment or discrimination. Transparency is vital. I communicate methodologies and findings clearly, allowing stakeholders to understand the implications of the data-driven decisions. Responsible use of data fosters trust and integrity in the work I conduct. 23. Can you discuss your experience with natural language processing, NLP? I have worked on several NLP projects, primarily focusing on sentiment analysis and text classification. One significant project involved developing a sentiment analysis model for customer reviews. This required preprocessing the text data, including tokenization, stemming, and removing stop words. I utilized libraries like NLTK and Spacy for text processing and TensorFlow for building the model. Challenges included handling sarcasm in text and ensuring model accuracy. By iterating on feature engineering and model selection, I achieved a high F1 score, providing valuable insights into customer sentiments for the business. 24. How do you handle feedback and criticism regarding your data analyses or models? Receiving feedback is essential for growth. I approach it with an open mindset, viewing criticism as an opportunity for improvement. When I receive feedback, I take time to analyze the comments carefully and determine their validity. I prioritize constructive suggestions that can enhance my work. If necessary, I engage in discussions with peers or supervisors for clarification and further insights. Implementing changes based on feedback not only strengthens my analyses but also fosters collaboration and trust within the team, ultimately leading to better outcomes in data projects. 25. What are your long-term career goals in data science and how do you plan to achieve them? My long-term career goals in data science include becoming a thought leader in the field by specializing in advanced machine learning techniques and their applications in real-world problems. I aim to lead a team of data scientists, fostering collaboration and innovation. To achieve this, I plan to pursue continuous learning through advanced courses, attending industry conferences, and participating in data science communities. Additionally, I seek mentorship from experienced professionals and actively engage in projects that push my boundaries, ensuring I stay at the forefront of technology and best practices. As we wrap up our exploration of the top 25 data science interview questions and answers, we hope you feel more prepared and confident for your upcoming interviews. Mastering these key concepts will not only enhance your knowledge but also set you apart in the competitive job market. Remember, practice makes perfect, so keep refining your skills and stay curious. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more insightful content on data science and beyond. Your support helps us continue to provide valuable resources for aspiring data scientists. Happy learning!